Welcome back. So we'll look at balancing equations. So we looked at naming ionic compounds, covalent compounds, acids, and bases. Now we'll look at equations. So I give quite a few examples and sheets to work through in the booklet. We'll do a few on this first sheet just to see how we do it. Now, there isn't a lot of room on this sheet. So you may want to, I'm going to use another piece of paper just so I can balance things out appropriately. So you may wish to do the same. What you may wish to do is, so first of all, bear in mind we have the old Hofbrinkel elements, right? The diatomic gases. So whenever we see the words hydrogen or fluorine, so for example here, oxygen, we know that that oxygen is going to be O2. O2. Hydrogen, it's a Hofbrinkel. In the natural state it exists as a diatomic gas. So that's one thing to consider. Otherwise, if I see iron, it's just Fe. If I see sulfur, it's just S. Even though sulfur comes in many different forms, such as S4, S8, we'll just assume it is this. And iron 2, if there's a Roman numeral, we know what that is automatically. And then sulfide. So if I can look over here, sulfide, S2 negative. So when you have two elements coming together in an ionic compound, and you know it's an ionic compound because here we have a metal and a non-metal, so we have to worry about balancing the charges. So I'm just going to recopy this over to here. So let's see here, number 1. So we have iron plus sulfide, and let's see, 2 plus, 2 minus, so they come together perfectly. So if we were to balance it, we have 1 iron, 1 sulfur, 1 iron, 1 sulfur. So it is balanced out perfectly. All right, let's look at another one here. Let's look at number 4. So potassium chlorate. Okay, so we looked at chlorate before. So chlorate, if we look it up over here on the chart, chlorate, it's ClO3 negative. ClO3 negative. So when it comes together with potassium, it's a nice 1-to-1. Potassium chloride, potassium coming together with chloride. You're going to get that. So we put that all together. So if we put that all together here, KClO3. And here we have one thing breaking down. So we can do that. And it says, over here if you notice it says heated. So we can have a decomposition reaction if we in fact heat something. All right, so that's what we end up with. So if I keep track of what I have, oops. So here we have 1, 1, and then we have 3 oxygens. 1, 1, and 2. So hey, this is balanced with the exception of that oxygen. Now, whenever you have an odd number of oxygen, notice I leave oxygen until the very end because a lot of compounds have oxygen in them. So I'd leave them till the very end. If you do have an odd number, try doubling it. And there's the bell. So double it. So if I double 3, because I can do it, I can double it to get 6. And what you're doing is you're making that odd number even, and then of course we can, whatever we do to this 2 here, it's going to be an even number as well. So here we have 2 Ks, and we'll have 2 Cls. 2 times 3 is 6. So now we should be able to insert coefficients here. 2Ks, 2 Cls, and I'm still left with a deficiency of oxygen here, but of course I can easily make 6 by chucking a 3 in front of there. So to balance, you have to put coefficients in front. We're not allowed to change the subscripts because that would be changing the compound itself. All right, so maybe we'll do one more here. How about number 8? One more, number 8, aluminum and oxygen. So aluminum, oxygen, because it's a Hofbrinkel, and we have aluminum oxide. So Al3 plus, O2 minus. So of course for that, let's see here, Al3 plus. And if I double that, I'm going to get 6. And then of course I can get 6 negatives by having 3 of these O2 negatives. So the formula for aluminum oxide is Al2O3. 2 aluminums and 3 oxygens. Okay, so that's what we end up with. All right, so if we write down what we have, 1 aluminum, 2 oxygens. And notice I'm keeping track of it in the same order too. So if I'm going aluminum oxygen on this side, aluminum oxygen on this side, 2, 3. So I could put a double the aluminums right there. But then again, I still have that same problem with the odd number of oxygens. So if I double this, so put a 2 in front of here to double that, so we have 6. Because 2 times 3 is 6. 2 times 2 is 4. And then, oh yeah, so I could go back and make 4 here by secretly changing that to 4 aluminum. So 4, 2, 4, 2. Okay, I think we'll do one more, number 10. Just to show you a little trick for this one. So iron 3, chloride, ammonium. If you recall, that is a positive ion right here on the left-hand side. NH4 plus, hydroxide, and then just reversed order on the other side. Whoops. So iron 3, so we have 3 irons and 1 chloride, so you know we're going to have 3 chlorides to make iron 3 chloride. Okay, and plus 1, minus 1, so ammonium hydroxide is just simply this. Iron 3 hydroxide, 3 irons, 1 hydroxide, so we're going to have 3 hydroxides. And of course we just can't leave it like that, right? Because that 3 looks like it's only applying to the H. It's applying to the whole OH group. And ammonium chloride, plus 1, minus 1. So we get that. Now, breaking this down, FeCl. Now, if you take a look here, ammonium NH4, it stays together as NH4. So what you can do is just treat it as an NH4 group. And same thing with hydroxide. It doesn't get split up. So we can get away with just simply calling it an OH group. And over here, I'm going to put it in the same order. And I know it goes iron, then hydroxide, but let's keep it consistent with the left-hand side. That way we can easily compare the two sides. All right, so over here we have 1 iron, 3 chlorides, 1 NH4 group, so we don't have 4 of them. That 4 is part of the group. And then 1 hydroxide. Over here, 1 chlorides, we have 1, ammoniums, we have 1, and then we have 3 hydroxides. Okay, so that gives you an idea of what we have. So iron, we're good. Chloride, we have 3. We're going to have 3 on this side, and we can accomplish that by inserting a 3 right here as a coefficient. So that tells us that we're going to have 3 ammonium groups and 3 chlorides. So 3 chlorides, but this is going to change to a 3. And so just go back to this ammonium. I only have 1, but I can easily make 3 by inserting a 3 there. That's going to give me 3 ammoniums. And look at that. It's going to give me 3 hydroxides, which is what I needed. 1, 3, 3, 3, 1, 3, 3, 3. So that is considered balanced. So yeah, so I think I assign at least the first page here. Go through that if you want extra practice. Of course, you can do the flip side. And I have other sheets there as well. So run through those. And this is a good assignment because you have to not only balance it, but because these are in Word format, you have to find the formulas first. All right, so try those, check your answers, and we'll see you again.